series of videos I am blending or fusing together a couple of different topics because that's how they love to do this in the exam. What I do is I talk you through the skills that you need for both of the topics that we will then blend in an example problem, and then you can try one yourself as an exam style one. This is inspired by a question from June 2017, paper 3, question 8, and I'll link that in the description as well. So the two topics are Pythagoras and some stuff to do with circles. So first of all, let's have a look at reminding ourselves with some things to do with Pythagoras. So if I'm wanting to find out the length of the hypotenuse here, this isn't me teaching this is just a quick recap. If you're finding the longest length, you square the other two sides, which is 4 squared and 6 squared, you add them together and then you square root them. So this is going to be for a calculator paper that we've got. So I'm going to do the square root of 4 squared plus 6 squared, which is 7.21, and I'm just going to do that to 2 decimal places. So we have 7.21 centimetres. Now the one underneath it is the same kind of thing. We're going to say that x in this case is the square root of 4 squared plus 4 squared, because we're looking for the hypotenuse here. So I'll do the square root of 4 squared plus 4 squared, and we get the answer that x's length is 5.66 to 2 decimal places. Now, I'm not explaining Pythagoras, I'm just saying this is how you do it. You should hopefully know this already. Now, the difference with this question is we're not looking for the hypotenuse, we're looking for a shorter side. So when we do the calculation, there's going to be a subtract sign rather than a plus sign in the middle. So if I'm going to try and find out what x is in this one that we have here, I'm going to start off by saying that x is going to be equal to the square root of the longest side, the hypotenuse squared, minus the shorter side squared, which is 4 squared. So it looks similar to a previous calculation, but it's actually going to be subtract instead. 6 squared minus 4 squared, square rooted, x is 4.47 centimetres, and that is to 2 decimal places. Now this one's a little bit trickier because I've actually got a repeat. I'm actually going to have to use the full version of Pythagoras' theorem. And now Pythagoras' theorem is that a squared plus b squared equals c squared. So I'm going to need to do this squared plus this squared to get the c squared, which is always the hypotenuse. So that is x squared plus x squared is equal to 4 squared. Well, x squared plus x squared is just 2x squared, and 4 squared is 16. Now I just need to solve this equation, so I'm going to half both sides so that I get x squared is equal to 8, and then I need to do the opposite of squaring, which is square rooting. So x is square root of 8, but I'll just quickly work out what that is on the calculator as well. Oh, there it was. Square root of 8 is 2.83 centimetres, and that is to 2 decimal places. So most of the time with Pythagoras, you can just figure out whether you're looking for the longest or the shortest side, but sometimes if you've got a repeat side, you might need to use the original Pythagoras' theorem that we have here. Okay, let's have a look at trying some of these questions. So we're going to blend this topic with the area of circles. Let's quickly remind ourselves of how you find the area of a circle. The area of a circle is pi multiplied by the radius squared. So this first one is just going to be pi multiplied by 3 squared, which is just 9 times pi. But let's get this in some decimals. We're going to do pi multiplied by, let's just clear this, pi multiplied by 3 squared, and we get 28.27 centimetres squared, and that's to 2 decimal places. They'll usually tell you in the question. So the area of this one, pretty simple, it's just going to be pi multiplied by 6 squared. So I'm going to let's just delete it on here. Pi multiplied by 6 squared, and that is 113.10 centimetres squared to 2 decimal places. Now the last one that we're going to have a look at is a little bit different because the diameter is 7 and the formula is only for the radius. So I'm going to have to use the radius here being half of that, which is 3.5. So the area is pi multiplied by 3.5 squared. Let's just quickly calculate that. So pi multiplied by 3.5 squared, and we get 38.48 centimetres squared. Okay, so now we're going to be looking at some other kinds of questions where we go backwards. They've told us the area and we want to find the radius. So if the area is 30, I'm kind of going to be using this formula that we've got to try and find the radius to work backwards. The area is 30, and I'm going to try and find out what the radius is. So I'm going to divide by pi so that I get the radius squared, and then I'm going to square root the whole thing to find out what the radius is. So I'm just going to put that straight into my calculator. I'm going to do the square root of 30 over pi. And so the radius is going to be 3.09 centimetres to 2 decimal places. Same thing for this one. The area is 15, so 15 equals pi times the radius squared, which we're going to try and find out. I'm going to make r the subject, so I will divide by pi, and then I will square root. So I'm going to do the square root of 15 divided by pi. So I'm going to do the square root of 15 over pi, and I get 2.19 centimetres to 2 decimal places. Last one, a little bit trickier. It tells us that the area is 20 centimetres. Now we have to use the area of the full circle. So the area of the full circle that we would have would be 40 centimetres squared. So we get 40 is pi r squared. So 40 divided by pi square rooted is going to be what r is equal to. So I'll just put that in the calculator, and I'm going to do now the square root of 40 over pi. And that tells us that the radius is 3.57 centimetres to 2 decimal places. Okay, so now we're going to put both of those things into context. We're going to blend together Pythagoras, and we're going to blend it with circles. So here's the example problem, and it's an exam style one that would be worth about 4 marks here. It says a right-angled isosceles triangle is inside a square. Okay, so this is a right angle that we've got here, and it's an isosceles because we can see that this one and this one are equal. And it says with one of its sides as the diameter. Okay, so we know that this is the diameter. I'm just going to say that must mean that's the center. So this is the diameter of the circle across here. The shorter sides have length x, great, I can see that. And each vertex of the triangle is on the circumference of the circle. Here, here, and here, it's touching the outside. And it says that the area of the circle is 30 centimetres squared. Work out the value of x, give your answer correct to 3 significant figures. Well, let's just kind of ignore the fact that there's even a triangle in there. Let's just think, what can I find out with this 30 centimetres? So I know that if I have a circle, I can find out what the radius is if I know that the area is 30 centimetres squared. I could find out what the radius is, which would help me then find out the diameter. So we know that the area is pi r squared. So 30 is pi r squared. So I'll do 30 divided by pi to get the radius squared, and then I will square root that to find out what the radius is. Okay, let's put that on our calculator and find out what 30 divided by pi is, the square root of 30 divided by pi. So we'll do the square root of 30 over pi, and it gives me 3.090, and I'm just going to keep going. Now, it looks like I'm actually going to want to find out what the diameter is, because I think we're going to be able to do something with Pythagoras in a second. So let's just write down the diameter. Let's just get that answer. You can just do the answer multiplied by 2. So the diameter is 6.18038 and just keeps going. Now let's think about what's coming up next. It wants us to work out the value of x. So the other thing that we've got going on in this is we've got a right-angled triangle. See if I can get it looking a bit neater than that. Last chance for me to get it right. There we go. We know that the diameter is 6.18 blah 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 that I have down here, and these sides are x and x. So I just want to find out the value of x. Well, this is going to look really similar to this problem that we did over here. So we're going to just repeat that process that we have. So we're going to use Pythagoras. And we know that Pythagoras' theorem is that a squared plus b squared equals c squared. So x squared plus x squared equals the 6.18038 all squared. So that is 2x squared equals 6.18038 all squared. So x squared will be 6.18038 all squared, and then divided by 2 because we need to half it. And so x is going to be the square root of that whole thing. Now I'm actually just going to find out what that is on the calculator so that we can type it in. So I've already got the 6.8 thing there, so I'm going to just do my answer squared, and then I'm also going to divide it by 2, so that I'm actually saying that this thing is going to be written inside there. So let me just get my pen back. So it's the square root of 19.098 blah 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 So all I need to do is just square root that answer, so I can just do the square root of the answer, and I get that x is 4.37 centimetres, and that is to 3 significant figures. So the answer to that one is 4.37. Okay, so you're going to have a look at this next question that we've got here that is kind of similar, slightly different. Pause the video and have a go. This is an exam style question, so kind of using the same ideas of what we've come across. So let me just put the calculator to the other side. Okay, let's read through what it says. We've got a square of side length x centimetres is inside a circle so that each vertex of the square is on the circumference. The area of the circle is 100 centimetres squared. Then it wants us to work out the value of x. Well, let's just use this information that we've got so far. They've told me that the area of the circle is 100, so I think that means I can find out what the radius is. The area is 100 centimetres squared, so I know that 100 is equal to pi r squared. So I can do 100 and I can divide it by pi and square root it, and that will tell me what the radius is. Hopefully that will give us something to be able to do this square that's on the inside. So I'm going to do the square root of 100 over pi. And that tells me that the radius this time is 5.6418 blah blah blah, and so the diameter is probably going to be useful too. I'm going to just do the answer times by 2, whoops, let's just say equals, and then the answer multiplied by 2. So the diameter is 11.2837 blah blah blah. Now that I know the diameter, I'm going to go to this triangle that I have over here. I'm going to create a diameter on here. Now you could have drawn the diameter like this if you wanted to, but it's not going to help us with the square. If we go from the corner to the corner, we know that that's going to be a diameter of the circle, and that is 11.2837 blah blah blah. And because it's a square, we know that the side length on the other side is also going to be x centimetres. So we've now got a right angled triangle, because we know that a square has got a right angle in one of the corners. We know that 2 of the sides are x, and the third side is the diameter that we've got there. So to find out what x is equal to, I'll do my a squared plus b squared equals c squared. That is x squared plus x squared equals the diameter squared, which I've already got on my calculator, so it's this number here, all squared. So 2x squared is that number. I'm going to find out what x is by dividing it by 2. I could keep it in the dot dot dots if I want to, and then after I've divided it by 2, I square root it. Make sure that you divide by 2 first, and then square root it. You can't square root and then divide. It won't give you the same answer. It will give you the wrong answer. So I've already got that stored on my calculator as the answer, so I can actually just type in instead. I can just put answer instead of this thing. So I'm going to do the square root of the answer divided by 2. And I get that my answer for x is therefore 2.3, so I haven't got the squared for the answer. No wonder it doesn't make any sense. So this is supposed to have a squared in there, so it's supposed to say answer squared. Let's just get that typed in properly, answer squared. And so we get the answer 7.978. So x is 7.978, and it wants it correct to 3 significant figures. So I'm going to write that as 7.98 centimetres to 3 significant figures. Now when my calculator gave me the answer of 2 centimetres, I just knew that 2 centimetres or 2 point something and 2 point something was never going to have a diameter of 11.7. I'm much happier with something that's close to 8. Something that's 8 by 8 is much more likely to have that one. So like I said, I'm going to link in the description to the exam paper that this was inspired by. If you find this helpful, just make sure you're subscribed to my channel, because I'm going to be doing loads more of these, and they're always going to be getting you those difficult questions towards the end of the exam paper.